Hello everyone, sorry I couldn't be here today, but we will be starting on properties of rectangles. So the properties of rectangles, they actually start off similar to the properties of parallelograms. So these are the 5 properties that I've taught you already. Again, we do not get rid of these. They stay and we still have to use them. That's why I wanted to stress so much about, making sure we understood these, because they apply to rectangles as well. But not only those, we also have 2 more. One does say that all 4 angles are right angles. So these 4 corner angles, they're all going to equal 90 degrees. So this is 90 degrees. And then the second property is that all diagonals are congruent. So this diagonal is going to measure the exact same thing that this diagonal measures. They still bisect each other, just like with parallelograms, but they are also congruent. So let's take a look at how we would do some of these in practice. The directions for number 1 do say that each quadrilateral below is a rectangle. Find the missing measures. So we do want to use those properties kind of as a checklist. So here I know I am using just sides, so I know only some of my properties will have to be applied here. My first property is that sides are parallel. We don't necessarily need that for this. However, my second property does say that opposite sides are congruent. So I know these 2 sides are congruent, and then I also know these 2 sides are congruent. So right off the bat, I know 10. This will also be 10, and because SR is opposite to PQ, that's going to be 24. So QR ended up being 10, SR ended up being 24. And then we have SQ. So I'm going to erase what I just drew so we can see this a little bit better. We are looking for SQ, so we are looking for this diagonal. And so we don't have any numbers for either of these diagonals, so it seems pretty impossible for us to find the length of that. However, if we recall our new property, that does say, this is property number 1, all 4 angles are right angles, which means this angle right here is a right angle, which then of course makes this a right triangle. What does that mean? That means that we can use our Pythagorean theorem in order to solve for the length of my hypotenuse. So the Pythagorean theorem does say a squared plus b squared is equal to c squared. Remember, my c is my hypotenuse, aka the side that is across that 90-degree angle. So this is going to be my c. Then this is my a, this is my b. Those don't matter, they are interchangeable. So when I replace my a and my b, this becomes 10 squared plus 24 squared equal to c squared. Oops, I forgot my square right here. Input that into the calculator. 10 squared is 100. Plus 24 squared, that is 576. That is still equal to c squared. Let's add these 2 up. That becomes 676 equal to c squared. Now we have to get rid of that square. For those of us who do not remember how, we just take the square root of both sides. Remember, that is second square on your calculator. And when we do that, we find that c is equal to 26. So this length right here will equal to 26. Then we are looking for PR. PR is this other diagonal right here. Oops, I completely missed that. You guys know what I mean. So because that is my diagonal, that is property number 2 that we learned, I know that they are congruent. So PR will be the exact same thing as PQ, that is 26 as well. And then QT, we are just asking for half of that diagonal. So in order to find QT, all I need to do is say 26, divide that by 2, and we get 13. At this point, I want you to do number 2 on your own. So pause this video, work that out, and then go to either Ms. Rajano, Ms. Battle, or your sub, and have them check your answers for number 2. Then we can move on to number 3 after you've done that. So let's take a second, pause this video, and work that out. So number 2 is all about angles. And we are looking at a rectangle. So if I were you, I would just go ahead and draw in my 90-degree angles every time I do a rectangle. That way I could just keep that in mind while I'm doing these. So my first question asks me for MJK. So I'm going to go MJK. We are talking about this entire angle right here. That, of course, is 90 degrees, as we have found out today. Next up, we are looking for MJL. So MJL right here, we are talking about this angle now. So this lets us know that this angle right here, oops, give me 1 sec. That angle right there does equal to 90 degrees. We just found that out. But this half right here is 27. So the way we can find the other half is just, of course, saying 90 minus 27. And we should get 63 degrees. So now we know this right here does give me 63 degrees. And while I'm here, I'm just going to go look at my alternate interior angles. So I know 27 will be here as well. Then I know 63 is going to be right there. Let's look at others now. We are looking at JLK. So let me grab another color. JL. Okay, luckily for us, because we went ahead and did our alternate interiors, that ended up being 63 degrees as well. We found that using alternate interior angles. Go ahead and write these down. That way, during your quiz, you have something to base yourself off of. So, okay, alternate interior angles, that's good. Then we are looking for KML. So KML, this is a little bit different. So we are looking for KML. We are looking for this angle right here. So what ends up happening is these actually become our triangle congruency theorems. So these are all triangles that become side-side-side triangles. Because, of course, these two are congruent, and then these two are congruent, and then I know this is congruent to that, this is congruent to this. Actually, that would be 3, huh? So, actually, no, that wouldn't. I did an extra one. But you guys get the point. All those sides are congruent. And so, because of that, and I do this wrong, these are supposed to be 2, what ends up happening is that all these angles are going to be some variation of these 2 numbers. So usually the inner ones match, so I know if this is 27, this angle here is going to be 27, and this is going to be 63. Of course, the 2 inner ones match. 2 inner ones, so I know this is going to be 63, not only because it is matching with this other half of the angle, but because it's alternate interior to this one. So that, of course, means 27. So going again, 2 27s, 2 63s, 2 27s, 2 63s. So for that is KML, and that will be 27 degrees. If you want to take an in-depth look at this mess that we've just made with our sides, you are most definitely welcome to. So I think this ended up being 27 and then 27 degrees here as well. And then lastly, we are looking for M and L. Here we have a triangle, and we have 2 of the 3 angles that we need. So for this one, we did have to use the sum of interiors of a triangle, which of course we've talked about many times before. That does equal 180. So all we had to do here is say 180 minus 27 minus 27, and that ends up being 126 degrees. Okay. With that in mind, let's go ahead and try number 4. Remember your angle theorems for number 4. So pause this video, go up to the sub, Miss Battle or Miss Rojano, and have them check your number 4 for you.